This is problem number 6 from the WebAssign. Anne is driving down a street at 57 kilometers per hour. Suddenly, a child runs into the street. If it takes Anne 0.79 seconds to react and apply the brakes, how many meters will she have moved before she begins to slow down? We're going to approach this problem by using the Guppies method. G stands for our givens. So, what information was provided to us in the problem? Well, we're told that she was moving at a speed of 57 kilometers per hour. I know that this is a speed because there's no direction. So I'm going to write speed equals 57 kilometers per hour. We're also told that it takes Anne 0.79 seconds to react. This is a time, I know, because of its unit of seconds. So I'm going to put t equals 0.79 seconds. All we know is that this is what occurs before she's able to hit the brakes. This means that she's moving at a constant velocity and she's in dynamic equilibrium. The next part of Guppies is to determine the unknown variables, or what are we trying to solve for. And the question is asking for how many meters. So how many meters is a measurement of the distance, d. P stands for proper units. We need to return to the given information, kilometers, hours, and seconds, and decide which one of these are in proper units and which ones need to be converted. Again, in physics class, we use kilograms for mass, seconds for time, and meters for distance. So we're going to have to convert this kilometers and hours to meters and seconds. So we'll start here. 57 kilometers per hour. I'm going to draw a fence post. And I know my conversion factors from kilometers to meters, as well as my conversion factor from hours to seconds. So in 1 kilometer, there are 1,000 meters. In 1 hour, there are 3,600 seconds. So I'm going to return to my fence post, and I'll start with kilometers because it's in the numerator. So in order to cancel out my kilometers, I'll put 1 kilometer on the bottom, and the other part of my conversion factor is 1,000 meters, so I'll put that in the top. The canceling of units, so my kilometers cancels and all I'm left with are meters. So I'm done with that phase of my conversion. Now I need to convert the hours into seconds. So I'm going to extend this fence post a little bit more. I'm going to put 1 hour in the top. Again, they're on opposite sides, so they cancel, and 3,600 seconds in the bottom. I know I'm completed because my hours have canceled, and the only units I have left are meters and seconds. So to solve, I'm going to multiply across the top and divide by any numbers that are in the bottom. This converts to a speed of 15.83 meters per second. Now I'll look at my picture or principle. Well, the idea behind this problem is that she's moving at a constant velocity. Because I'm moving at a constant velocity, I can use my velocity or speed equation. I am now ready to substitute and solve. I'm going to do so over here on this side of the screen. And if you remember, we converted to meters per second. So that's the unit that I want to use in my equation. So I'm going to put 15.83 equals a distance, which is what I'm solving for, so I leave that as a variable, divided by the time of 0.79 seconds. To solve this, I'm going to multiply both sides by 0.79. So on the right side of my equation, the 0.79's cancel, and I am left with 12.51 meters as my answer. And that's it.